the problem I picked is from section 7.1, it's example 3. And obviously I'm going to be using integration by parts for this because that's what this section is about, but I wanted to explore 2 other methods to see if I could use them because frankly they're easier. I can't use u substitution because the derivative of x squared doesn't cancel out with e to the x and vice versa. And then I can't split it into 2 integrals because these terms are multiplied and not added. So I'm going to use the integration by parts method. So I'm just going to label all my parts and then correctly differentiate or integrate them. So I labeled my x squared as u, and then my dv is e to the x, and then v is e to the x, and then du is 2x dx. So then I'm just going to be solving that by following the formula in the top right corner of my paper. So u times v is x squared times e to the x, and then minus the integral of e to the x times 2x dx. And I still can't solve that integral right away, so I need to do another version of integration by parts where I assign letters to each of the parts of my equation. I'm going to assign e to the x as dv, and then v as e to the x, and then I'll assign 2x as u, and then du will be 2 dx. And then I'm just writing out my equation. Can't forget the negative sign, so then uv is 2x times e to the x, and then minus the integral of v, which is e to the x, and then du, which is 2. And so then I'm just going to solve that integral. The antiderivative of e to the x is just e to the x, and then you multiply by the 2. And then if you plug it back in to the second integral I made, negative e to the x times 2x. So we're going to need that top part that I put in a square. So the final answer will be x squared times e to the x minus the quantity of 2x e to the x minus 2e to the x, and then plus c. And that's the final answer.